The heart, a muscular organ roughly the size of a fist, functions as a pump and is located slightly left of center in the chest. The primary function of the heart is to provide blood circulation throughout the body, enabling the transportation of vital nutrients and oxygen to each cell. This circulation process is critical for sustaining life. After delivering oxygen to the cells, the arterial blood becomes venous and returns to the heart through other vessels. The heart beats approximately 100,000 times per day, 40 million times per year, and up to 3 billion times over an average lifespan. Let's talk about the structure of the heart in more detail. Composed of several layers of robust muscle tissue, the heart features a thin layer called the pericardium, which covers its exterior. The inner walls of the heart are lined by the endocardium. The heart is divided into 4 chambers, 2 upper and 2 lower. The upper chambers, known as atria, receive blood as it enters the heart. The lower chambers, called ventricles, pump blood out of the heart. The heart chambers are separated by valves, which ensure proper blood flow direction. The valves are named tricuspid, pulmonary, mitral, and aortic. The deoxygenated blood enters the right atrium of the heart. In medicine, this moment is considered the beginning of the cardiac cycle. Next, the right atrium contracts, pushing the blood through the tricuspid valve and into the right ventricle. From there, the blood flows through the pulmonary valve into the pulmonary arteries and is transported to the lungs, where it receives oxygen. Oxygen-rich blood returns to the heart via the left atrium, where it proceeds to the left ventricle. From there, the freshly oxygenated blood is pumped throughout the body through the aorta artery. With each heartbeat, occurring approximately once per second, the heart alternates between contracting and relaxing. The contraction phase is known as systole. The relaxation phase is referred to as diastole. During systole, the ventricles contract, propelling blood into the vessels that lead to the lungs and the rest of the body. The right ventricle contracts slightly before the left ventricle does. During diastole, the ventricles relax and fill with blood arriving from the upper chambers, the left and right atria. Subsequently, the cycle starts again. The heartbeat is generated and coordinated by specialized cells in the heart that produce and conduct electrical signals. These signals spread throughout the heart muscle and cause it to contract and relax rhythmically, pumping blood through the circulatory system. The cardiac conduction system is composed of several components, which include the sinoatrial node, SA node, located in the right atrium near the entrance of the superior vena cava. The SA node acts as the heart's natural pacemaker, generating electrical signals that initiate each heartbeat and determine the heart rate. These signals spread throughout both atria, stimulating them to contract. The atrioventricular node, AV node, is located on the opposite side of the right atrium, near the tricuspid valve. Acting as an electrical gateway to the ventricles, the AV node delays the passage of electrical impulses to these lower chambers. This pause ensures that the atria have completely ejected blood into the ventricles before the ventricles contract. The AV node receives signals from the SA node and subsequently transmits them to the atrioventricular bundle, also known as the AV bundle or bundle of His. The bundle branches into the right and left divisions, which direct the impulses toward the apex of the heart. The signals are subsequently relayed to the Purkinje fibers, which turn upward and disperse throughout the ventricular myocardium. These signals prompt the heart muscles to contract and relax, facilitating blood circulation throughout the body. This cycle of contraction and relaxation perpetually repeats 24 hours a day, 7 days a week, for the duration of our life. One essential parameter is the heart rate, which measures the number of times the heart beats per minute. It provides critical information about the heart's function, overall health, and response to exercise or stress. The heart's beating rate can vary, adjusting in response to the body's physical needs or emotional states. The autonomic nervous system regulates heart rate, involuntarily adapting it in response to different stimuli.